All right, so we're going to round the answer to the nearest tenth on this one. But what is it asking for? It's asking us to find the missing length of this right triangle. So it is a right triangle. We get to assume it's a right triangle because this lesson is called the Pythagorean Theorem, which only applies to right triangles. But the values that are given, I see, even though it's not showing, that this angle right here would be my right angle. And they're not going to throw any funky business on you where it's like, oh, this looks like a right angle, but this is actually the hypotenuse. They're not going to do anything like that to you because it's a Pythagorean theorem lesson. But I can see that I'm going to start with this one right here, is 12. That's a leg length because the legs make this right angle. 1, 2 legs right there. Now, of course, this one's color-coded, but it shouldn't need to be for us to be able to solve this. So I'm going to say that this first leg is 12. If you wanted to make it this leg is 12, you could do it as long as you make the other one 5. But for me, the first one is going to be 12. The second leg here is 5. So I'm going to say that this leg here is 5. Now that I know those two lengths, I'm going to solve for the missing one, which is the hypotenuse. So I'm going to square the 12, square the 5, add them together, and then this will equal the hypotenuse as a square, like this. Now I could solve this at one time on the calculator, but I'm going to do the work, well, a little bit of work here. So first up, I'm going to do 12 times 12. That's 12 to the power of 2, which is 144. Then I will do 5 times 5, which is 25. Okay, why am I doing this? Because it's an order of operations problem right now. And now that I have that, I'm going to add those two values together, and then this would equal the hypotenuse as a square. And since we are on order of operations, we did exponents. There was no parentheses. We did exponents, no multiplication or division. But now I'm going to need to add these two numbers together, which again, I would just do in the calculator. 144 plus 25 is going to be 169. And this is going to equal the hypotenuse as a square. Now, what I would like out of this is just a regular old-fashioned hypotenuse and not a hypotenuse as a square. Okay, so this is what I'm trying to get. This is what I have. I can't have the exponent there too. So I need to undo the exponent or get rid of it. And to do that, what I will need to do is take that hypotenuse as a square, and I'm going to need to square root it. But if I were to do this to one side, it's a principle of equality. Now I must do it to the other side. Now, generally speaking, we'd get two answers out of this, but since we're looking at lengths of a triangle, we only need one of them. So in the calculator, to access the square root symbol, you push second in the top left, and then 4 buttons down, you got the x squared button, and you can see right above the x squared is the square root symbol. So second, x squared, and then you type in your 169, enter, and the calculator will tell you, okay, the hypotenuse is 13 units. Now, this does not have any labels, so I'm not going to label my answer. But I do know that my hypotenuse is 13, so I'm going to put in here. I'll write it right there just so we can see those lengths. And these three values, since there are no decimals, this is what we call a Pythagorean triple. So back in Pythagoras' day, they went through and they're like, holy crap, we can make right triangle lengths, leg lengths, and hypotenuse, and there's no decimals. Because usually if there's decimals, you have to do some rounding. But in these cases, they were like, no decimals for us. And then they celebrated, and then they ate triangle-shaped sandwiches and maybe killed some people. But either way, the hypotenuse is 13. That's it. I was talking about you could have taken a shortcut. So if I were to go back to this step right here, so it was hypotenuse squared equals some stuff. And we knew all the stuff, by the way. So if I wanted to, I could have gone back to the calculator and just typed this whole expression into the calculator. Because if I were to square root that hypotenuse squared, I could have skipped all this stuff right here and then just got 13. So you can try that. You type the square root. So you put the square root in first. That's second x squared. 12 squared plus 5 squared. Push enter. Boom. And it's going to skip all this work and just give you 13. You don't have to do that, but it's one way to do it.